Okay, you have your ISN out. We've already done the tangent ratio, so that was your first page. We're going to the page that says sine and cosine ISN. I'm up on the screen in a moment. All right, the trig ratio involved the legs of the right triangle. Using the tangent ratio, we only use the legs. We only use the two legs of the right triangle. The tangent of theta was opposite leg compared to the adjacent leg. We did not use what? What part of the triangles did we not use? Yeah, we did not use the hypotenuse. Now we will learn the sine and the cosine, which will use, I did a typo there, I forgot the word use, which will use a leg and the hypotenuse. Okay, anybody still need this? All right, find the sine and cosine of the acute angles in the right triangle shown. If you like using highlighter, I'm going to look at the sine of angle A. A is coming from the corner where A is. So that's where you're looking from. If you are coming from there, the key things to do is to note where your hypotenuse is, which is always across from the right angle. So this is the hypotenuse. In relationship to that angle, the 6 is opposite the angle A. So 6 would be the opposite leg. And the 8 would be the adjacent leg. So if the hypotenuse, the sine ratio is a comparison of the opposite to the hypotenuse, we would be writing 6 over 10. And then we would reduce that to 3/5. The cosine of an angle is the comparison of the adjacent leg to the hypotenuse. The hypotenuse will never be in the numerator of your ratios. So the leg adjacent to angle A would be the 8. And 10 is the hypotenuse, so 8 over 10. And that reduces to 4/5. Now we're going to come from another angle, angle B. So I'm going to use a different color to highlight angle B. If we're coming from this angle, where B is, then now things have changed. What side is opposite it? So I'm using the color on purpose because now I'm coming from this angle, which I labeled in pink. This side, where the 8 is, would now be the opposite side, or the opposite leg. And this side next to it would be the adjacent leg. And the hypotenuse is still the hypotenuse, okay? So now I'm ready to write the ratios for angle B. The sine of B would be opposite leg to angle B, which would be the 8 over the hypotenuse 10. Reduce that to 4/5. Coming from angle B, the adjacent leg is the 6, and the hypotenuse is 10, so 6 over 10, and that reduces to 3/5. Okay? So you just have to pay attention to what angle you're coming from when you name your sides. Right, and I did those all in the pink. I guess I could color these. Now we're going to set up some trig ratios, and we're going to decide what one to use. Now, I know you haven't got a ton of room up there. I'm going to go back to this page one moment because all we did here, we had a lot of room right here. And I said to you that I had used a mnemonic instead of a SOHCAHTOA. And I'm going to continue with the tangent as well. Do you remember what I said to the sentence I came up with or said to use? Other teachers use it too. I don't do SOHCAHTOA because I can't, I think some kids don't remember how to spell it, and this is an easy way. On your calculator, it appears sine, then cosine, then tangent in the middle. And I said, Oscar has a heap of apples. And you just write the first letters of each of those words. Oscar has a heap of apples. No, it's sine, cosine, and tangent. I know you guys are going to be saying in your head sin, cos, and tan, but it's really sine, cosine, and tangent. Those are abbreviations. All right, we just did sine and cosine today. What? Right? If you remember that, you should be able to write down quickly what the ratios are. All right, on number 1, find the missing side, use sine or cosine, show setup, equation. You need to give the equation. So if I'm coming from the 57-degree angle, that's where we come from. We never come from the right angle. Then the side across from it is the opposite. And then the side that is across from the 90 is the hypotenuse. So what would we use? Sine or cosine? Okay. Oscar has, sine of an angle, Oscar has. You have it right on your paper, guys. Cosine of an angle, a heap. Tangent of an angle, of apples. This is opposite and hypotenuse. There's the one to use, sine. So our setup would be the sine of 57. This is our equation. Equals. Opposite leg has an X on it. Hypotenuse has a 14 on it. We treat it like a proportion by putting a 1 under the sine of 57. We multiply across. X times 1x that'd be 1x. And the other side, 14 times the sine of 57. So you grab your calculator. What's the first thing you should check? The degree mode, right. You want to press mode. Make sure it's in degrees. If it is in degrees, you're ready to go. If not, change it to degrees. Then type 14. Press the SIN sign button and put in 57, the angle measure, and hit enter. All right, so we're going to write units after it, 11.7 units. Because we don't have a measurement, but we know it's a measurement, a length. Okay, look at the difference between that one and the next one. We're coming from the 52 degrees. The hypotenuse is always across from the right angle, so we know we're using sine or cosine. The 23 is next to the angle, so it's called the adjacent leg, and this is the hypotenuse. So adjacent and hypotenuse is the cosine. We're working with a leg adjacent to the angle and the hypotenuse. You see how you have a little sandwich here? The angle's included between the sides. That's always cosine, okay? So the cosine of 52 equals 20 over x. You can't always assume that x is going to be in the numerator. It's not. X is on the hypotenuse. We're finding the hypotenuse, so x is in the denominator of the setup. We multiply across, and we get x times the cosine of 52 equals 20. Now we divide by the cosine of 52. So we type 20 divided by the cosine of 52, and give me your answer. So we type 20 Better be practicing typing these. Divided by cosine 52. Yes, you have it right, Nathan. 32.5 units. Anybody not getting 32.5? Nathan? All right, at the bottom of the page, again, I have it repeated. The Oscar has a heap of apples, and then there's the SOHCAHTOA in the box, depending on which one you prefer. Remember all three trig ratios you can use. I like to use Oscar has a heap of apples instead of the SOHCAHTOA. Whatever works for you is fine with me. We're going to find the missing side, and you got to decide what to use. So you have to go to your picture. You have to learn to determine which trig function you're going to use. That's where the angle is. Now, across from it is its opposite leg. I'm recording. Next to it would be its adjacent leg. When I see that, I think, okay, opposite and you guys, I just made a mistake because I got distracted. What's wrong with what I just labeled here? Is that the adjacent leg? No, it's the hypotenuse. It's across from the 90. Now, we might say, well, wait, it looks like the adjacent leg because it's next to the angle, but it's not the adjacent leg. This would be the adjacent leg because it's across from the 90, it's the hypotenuse. Sometimes maybe it's just good to go through them quick and identify all the hypotenuses. Hi, thank you. Okay, you're on a mission. I know. All right, so we had opposite and hypotenuse. This one would have been the sine. Okay, so the sine of 70 equals the opposite leg 17 over the adjacent leg x. What happens when we have an x in the denominator? Yep, you'll be dividing. X times the sine of 70 equals 17. So x is going to be 17 divided by the sine of 70. Got 18.1 units. I kind of don't have a lot of room because I write pretty big here. I'm going to write number 2 up here. But first I need to identify which trig function I'm going to use. I already highlighted the hypotenuse because it's across from the 90. The angle that we're coming from is the 58. And I don't see anything on the leg opposite it. Okay, so that's going to be adjacent and hypotenuse. This is the adjacent leg. And this is the hypotenuse. So that's going to be the cosine. So I'm going to have, say, cosine of 58 equals adjacent leg 14 over hypotenuse x. Oh, I got another one where I have to divide. So it's x times the cosine of 58 equals 14. And if you do not have to write this step right here, as long as you know what to type in the calculator. If you need to write it, it just helps you see what to do. Divide by cosine 58. So our answer is going to be 14 divided by the cosine of 58. And then I'll go find out what that is. Well, now's the time to get it straight. Okay. Oh, I see. 26.4 would be the value of x for this problem. Uh-oh, you're not getting 26.4? Okay, you need to divide 14 divided by cosine 58. And that's why I'm asking if you got it, because that's important. We have to make sure we're typing it in correctly. All right, what about the next one? Coming from 24 degrees, the hypotenuse is labeled in blue. And then right next to it is the other side that has a label on it, and it's the adjacent side. So adjacent and hypotenuse again. That one's another cosine. So the cosine of 24 equals adjacent leg x over hypotenuse 10. So we're just going to calculate it. X equals 10 times the cosine of 24. I just can't see my little screen. There we go. 9.1 units. All right, go to the angle you're coming from. This time, across from it, there's an X. So this would be your opposite, O. Oh, this is another leg. The hypotenuse is blank. So this is an adjacent side. So opposite and adjacent, which one is it? Guys? Tangent. Okay, legs, both legs. Tangent of that 37. Kind of covered it up. X over 18. All right, we're going to calculate it as x is 18 times the tangent of 37. You can skip even typing that times. You can just hit 18 and then the tan button. All right, Nathan, 13.6 is correct. Okay, I did quite a bit of notes for you in this. Go to the page. That's next. I made that page that you just did. I added it in. And then on here, let's right triangle trig 8.4, right? And then I drew in some extra triangles. And the reason I did that was to help make sure that we're clear about how to label them based on what angle we're coming from. This little symbol right here is read theta. That's the name of it. It's theta. It's a Greek letter. It's just as well be an X, okay? It's just a letter for an angle. They use Greek letters. You read that and you say it's called theta. So this would be sine of theta, cosine theta, tan theta. And it's in lots and lots of math books. You'll see it again. All right, so if theta is this angle, then this would be the opposite, this would be the adjacent, and the hypotenuse would be here. But what if theta was up here? So I drew this in for you, because if theta is at angle B, then you don't have the same labels. What stays the same, though? The hypotenuse. Okay. The hypotenuse does not change, but if you're coming from this angle up here, then this is now the opposite leg. And from here, this one is the adjacent leg. That's why I put in those extra triangles. So then I have for you a few more because I wanted you to be able to turn them different ways. and identify the angles from the angle what's what. So I drew all this, and we're going to label it. I put blanks in for you, and I'm just going to use letters. We had one more down here. So no matter which way we turn it, we want to know what to name those sides. Okay, if you feel comfy with highlighting your hypotenuse, if you like to get that out of the way, they're always across from the right angle. Okay, so in the first diagram, the hypotenuse is right here. What would be the side on the left of theta? Yep, that's your adjacent leg. And then across from theta is your opposite. If theta is here, the hypotenuse, of course, is always across from the right angle. So I'm just going to use an H, please. Across from theta would be your O, opposite leg, and next to it would be your A. Right now I left this one. It's more what it's going to look like when you go to do a problem, okay? If you're coming from theta, first I got the hypotenuse right here, put an H on it. Right next to the angle would be adjacent, and then across from it is opposite. You feeling like you could label those pretty easily? If you can do that, you can do these problems. Okay, so let's see what happens. All right, that's already there for you guys. You already saw that. Let's do a couple more examples. We got actually 6 more in the ISN. Okay, so we come from, by the time we get done with this ISN, we probably know what we're doing, I hope. Okay, first thing, hypotenuse, across from the 90. Then say from the angle, what is X? Is it opposite or adjacent? Yeah, opposite. Yep, adjacent. Opposite. Now, if you want to write down anywhere, if you want to write it down at the bottom of your page, the sine of an angle, and I didn't mean to keep highlighter, is Oscar has, just use your OH. Cosine of the angle, keep talking about Oscar. Oscar has a heap. And then tangent of an angle, he has a heap of apples. And you've got all your ratios quickly written down. All right, so which one are we using here? We have an O and an H, so it's sine. So sine of 60 equals X over 13. 13 sine 60 equals X, or X equals 13 sine 60. I don't care what order you write that. You're just going to be typing in your calculator probably anyway. It ought to be 11.3. units. Number 2. Yes. I'm putting them on every one of them. And that's because we're going to be finding angle measures also, and I want you to label those with degrees. But we're not doing angles until tomorrow. Well, we'll see if we get to it tomorrow. All right, here's the hypotenuse. It's across from the 90. Then go to the angle that you're given, which is the 20, and say, what is X? It's right next to it, so it's called adjacent. All right, so we got adjacent and hypotenuse. That's the cosine. Setup is cosine of 20 equals X, adjacent leg, over hypotenuse 12. So this is going to be X is valued at 12 times the cosine of 20. Does it? Well, that's unusual. It is. 11.3. No relationship though to the last one. Yeah, I know. I'm sorry about 3 and 4 and 5 and 6. I should have spread them out a little bit. Really? Guys, come on. Not possible. So, all right. Next to the 861 is the leg here. That would be your adjacent leg. Now, whoever has to listen to this recording will probably be quite aware that there's been some distractions. Adjacent, hypotenuse, this is the cosine. Share that with some parents, maybe. I just wrote the wrong angle. So cosine of 61 equals your adjacent leg 14 over x. And I know for you that are writing big, this is a little cramped, but we got plenty of room to do the last ones at the bottom. So use your room here to make sure you have good notes. Cross products. We got x times the cosine of 61 equals 14. Do not jump the gun with this one. You're not going to be multiplying, you're going to be dividing. So we take 14 divided by the cosine of 61. It is the way to find the missing sides in a right triangle. Okay, so x is 28.9 units. We just were able to find, using right triangle trig, the length of a missing side. Okay, so it's good to identify your hypotenuse right away. I'm going to go to number 5 just because it's right underneath that one. Okay, now I've been doing my adjacent legs in green. I've been doing my opposite legs in pink. This one's far away from the angle. It's across from it. So this would be your opposite leg. So if I have O and H, I'm using sine, cosine, or tangent? Sine. Okay. So the sine of 18 degrees is equal to x over 13. Opposite leg over hypotenuse. So I got x equals 13 times the sine of 18. Got 4.01. If you're going to the nearest tenth, you would actually write 4.0 because you would show that you actually knew how it rounded. Back to number 4, please. Across from the 90, there's an x, and it's the hypotenuse. Oh, well, that's nice that it's the hypotenuse on that side, too. All right. Coming from the 28, this side is across from it, so it would be the opposite leg. So I have another one that's sine. Yep. The sine of 28 equals opposite 11 over adjacent x, or no, over hypotenuse x. Uh-oh, x is on the bottom, so careful. X times the sine of 28 equals 11, which leads me to the division. In an accent. So I type 11 divided by sine 28. That's quite enough. .4 units. Yes, that's the point of the practice. All right, if we come over and find where our angle is that we're given. Good. Opposite, and this one would be adjacent. Yep. Are you working, is the hypotenuse labeled? No. That's tangent. 2 legs, you're doing tangent. Tangent of 43 equals x over 15. Nathan, you need to knock it off. But it's just been nonstop comments. 15 tan 43. All right, I'm guessing some of you are ahead of me. 13.98 would round to what? 14.0 units. Well, if you were correctly being asked to round and you were being graded on whether you rounded correctly or not, you did not show that that's the place of the 10. That's why it's supposed to be there. It's just showing that you rounded it. Yep. Okay, so now we're going to go today to the 8-4 packet that you got off the podium. And we're going to get this down. We are quite a ways into the chapter at this point. We have one more topic that uses sine, cosine, and tangent. We're going to do some applications next week. And tomorrow we will be having a quiz on special right triangles and Pythagorean theorem. May have a tangent problem, and I may just check if you can set one up or not. Tomorrow we have a quiz on the special right triangles, and I will do a little review before it. Okay. Writing the 3 trig ratios. Now I'm going back to a type of problem that's a little different than what we were just doing. We are coming from a particular angle at a time. That's why I'm going to use 2 colors. If I'm coming from angle W, then I would name my parts of my triangles differently than if I'm coming from angle T. So if I'm coming from angle W, then 4 is the opposite. 3 is adjacent. I'm going to do them all in yellow because I'm labeling opposite and adjacent based on angle W. 5 is the hypotenuse no matter what. Okay, now, coming from W, writing these ratios, all it's asking you is when it says to write the 3 trig ratios, you're going to write a fraction, a reduced fraction. If it can be reduced, you need to do it. Okay, remember a ratio is a comparison of 2 numbers. So what would the sign of W be for this triangle? 4 over 5, yes, Kate, 4 over 5 would be correct because that would be opposite over hypotenuse. If you need to write down your trig ratios, but you have them at the top of the page, I believe, or no? Okay. Or if you want to write them down, you can go through and do sine of an angle equals Oscar has, cosine of an angle, a heap, and then tangent of an angle of apples. All right, so then cosine from W would be adjacent over hypotenuse, 3/5. And the tangent would be opposite over adjacent, 4/3. I don't care. Your phone is not supposed to be out. Okay, last time. Using the same figure above, write 3 trig ratios for angle T. And now we're coming from angle T. If you're coming from angle T, this is now, the 3 would be your opposite leg. The 4 would be the adjacent, and the hypotenuse stays the same. So opposite over hypotenuse would be 3/5. Now I'm coming from angle T instead of W. The cosine would be adjacent over hypotenuse 4/5. And the tangent from T would be opposite over adjacent 3, over 4. Do you notice something about the relationship from these above? Sorry, I don't like that number. I want to be able to write that clearly. Okay, you see how the tangent of W and the tangent of T are reciprocals? Okay, the cosine of W is equal to the sine of T, and the sine of W equals the cosine of T. Just flopped around. So you have to have them in the right order. All 3 trig ratios are needed because the clues in each problem vary. Sometimes you're given clues about the legs only, so that's when you use the tangent. Okay, if you only have legs, you use tangent. In other problems, the question might concern the hypotenuse, in which case you would use the sine or the cosine. Write a trig equation for each of the following and solve. Now, these have already been given hints. It tells you what to use. So what I'd like to do, I'm going to just do 1, 2, 3 of these, and then I'm going to move further into the packet. Okay? This one says use the tangent. You're coming from here. X would be opposite, and the 20 would be your adjacent. So the correct setup for this problem is the tangent of 27, Cheyenne, please, is X over 20. Cross multiply. X equals 20 tan 27. And you guys know that we're going to type that now in the calculator. Okay, yes, 10.2 units. Pardon me? Well, this is your adjacent leg. This is your hypotenuse. It's already telling you to use the cosine, and that's because we have adjacent and hypotenuse. Cosine of 60. Did you get 16? Then you did it right. Cosine of 60 would 60 would be 8 over x. Okay, this is the kind where you have to divide, because you get x times the cosine of 60 equals 8, and then you divide. So x equals 8 divided by the cosine of 60, and that comes out to 16 units. This one specifically tells you already to use the sine, and that's because the x is on the opposite leg, and this is the hypotenuse where the 50 is. Right, so we say sine of 13 equals x over 50. That's the ones we think are easier because we don't have to divide. X equals 50 times the sine of 13. $11.2 if you went to the nearest tenth units. Do they need this still? All right, this tells you what to use. I'm going to let you work on those. We're going to move a little bit further in here. Now it says use an appropriate trig ratio to solve for x. I believe you have to turn the page. No, oh, you don't? Okay, let's see if we can identify fairly quickly which one you would use. At some point, you probably won't need to do highlighting anymore or labeling. So from the 60, where's that? No, where's the X? What is it? Opposite leg adjacent. Opposite. This one's hypotenuse. Do you know which one to use now? Okay, let's try just setting these up. The hypotenuse on number 2 is blank. The hypotenuse on number 3 has a number on it. So now I know on number 2, I won't be using sine or cosine. I will be using tangent because this is opposite, this is adjacent. In number 3, the side opposite is blank. This is the hypotenuse, and this is the leg that's adjacent. So which one? OH is going to be sine for number 1. Opposite over adjacent is going to be tangent for number 2. And finally, the third one is going to be the cosine. Cosine of 75, bless you, equals x over 18. And none of those makes you divide so far. All right, I'm going to let you calculate them later. Now, your scientific calculators, if you have one at home, I know not everybody has a graphing calculator. They do have sine, cosine, and tangent on them. Okay, and that's the kind of calculator you're supposed to have as a requirement of the course. Hopefully you can calculate some of these at home. Let's see. How about, what do you think number 4 is? Let's start asking around, guys. Sine, cosine, or tangent? Michael? What do you think? Yep, opposite and adjacent. Okay, so tan 25 is equal to x over 18. So I'm going to ask you guys to set me up on these, and don't sit here and calculate right now. Let's just get some set up because that's half the battle right there. All right, so what do I want to do, Jace, for number 5? Okay, hypotenuse is 96, good. So now you know you're going to use sine or cosine, so which one? Okay, now if you were going to use the sine, you'd need to have something on the side of opposite across from it. This one is right next to the angle. So that's an adjacent side, okay? This one's the hypotenuse. That's going to be Oscar has a heap. That's your cosine. Cosine of 50 is going to be x over 96. Okay, you see why it's cosine? Because this one is the one, just do that arrow. If you even made that arrow, you would see that what's on it. If you always want to go from here and then go like that, that's your opposite leg, but it's blank. Okay, so I got to use the ones that have something on them. All right, so coming from number 6, let's see if you can identify quick. That one's got the opposite, and this one is the hypotenuse. Now that I have opposite and hypotenuse, that one's the sine. Sine of 15 equals x over 29. Okay, I'd like you to work on getting them at least set up. If you feel like you don't have a calculator that works, please set up the problem so we can see if you're doing that right, and then we can get some calculations made. You might want to look over in your ISN, the special right triangles and Pythagorean theorem. You will be able to use your ISN, and we will do a review before the quiz. See you tomorrow. Have a good day. Thank you.